Choose a complete dinner from a dinner menu that allows a customer to choose from 2 salads, 3 entrees, and 2 desserts. So our first choice is either salad 1 or salad 2. And then we have 3 entrees. So there's 3 options after we pick salad 1, as well as 3 options after we pick salad 2. So salad 1, entree 1, salad 1, entree 2, salad 1, entree 3, and then the same for salad 2. And then we have a choice of 2 desserts. So from each of these branches, we have 2 options. So these are the 12 total outcomes. What is the probability that the customer chooses dessert type 2? So that would be these 6 out of the 12. So 6 over 12, which reduces to 1 over 2. What is the probability that the customer chooses salad type 1? And that would be these 6 out of the 12. Which reduces to 1 over 2. So as you can see, if you are trying to figure out how many possible outcomes there are for a given situation, using a tree diagram can be quite tedious, especially if you have to do more than 12 possible outcomes. So this is where the fundamental counting principle comes in. And this says if you can choose one item from a group of X items and a second item from a group of Y items, then the total number of 2 item choices is X times Y. So you just need to multiply together the number of choices for each group. So number 4 says use the fundamental accounting principle to find out how many complete dinners you can make from a dinner menu that allows customers to choose from 2 salads, 3 entrees, and 2 desserts. So this is actually the same question as number 3. So we know that the answer should be 12, but they just want us to use the fundamental accounting principle. So we have 3 different groups. We have salads, entrees, and desserts. So 2 salads times 3 choices for entrees times 2 desserts, and 2 times 3 times 2 is 12. So that takes a lot less time than having to map out the entire tree diagram.